Okay, here's a question from homework number 11. A thief steals an ATM card and must randomly guess the correct 4-digit PIN code from a 6-key keypad. Repetition of digits is allowed. What's the probability of a correct guess on the first try? So let's remember that the probability of any event is equal to the number of successes. And I write this over and over and over again because I think it just needs to be drilled in, over total possible outcomes. Now, in a question like this, in fact, this is pretty easy part to figure out. How many correct guesses are there? There's just one, your PIN code. There's just one possible success. However, the total possible outcomes part, that is the tricky part. The how do we figure that out? The total possible outcomes. All right, so this is where we need to really think about this. Now, this is a 6-key keypad, which is kind of strange, but it might look something like 1, 2, 3, 4, 5, 6, or something like that. You only have 6 digits to choose from on the keypad. It could be any 6 digits, single digits, but so it's not a full 10 digits that we have to choose from. And we need to choose 4 of them. You're going to create a 4-digit PIN code. So let's think about your PIN code. You're going to have your first digit that you choose, your second, your third, and your fourth. All right, of these 6 digits, how many can I choose? Well, I can choose any of them. I can choose any of the 6. I have 6 choices. All right, so because remember, this isn't a probability. This is actually figuring out the number of outcomes. For the second digit, I also have 6 choices because I can double up. I can choose a 4 and a 4 twice. I have 6 choices for the third digit, and I have 6 choices for the fourth digit. So that is going to be equal 6 to the 4th power, which if you do that on your calculator, you will see is 1,296. Different ways. That's a lot of different ways that you can come up with a PIN code using just these 6 digits. So the probability of a thief guessing your correct breaking into your PIN code, getting it correctly, and having access to whatever it is your PIN code is, your phone or your bank account, your ATM card, whatever, is going to be 1 over 1,296. And that seems like not a very likely probability. However, kind of think about it. You'll notice, I'm sure, imagine some of you with smartphones and things, you sometimes are advised to pick a 5-digit code instead of a 6-digit code, or instead of a 4-digit code. Well, think about it. Think about how much safer that is just by adding one more digit. If you're doing 5 instead of 4, 1, 2, 3, 4. And again, using the same choices, we have 6, 6, 6, and 6, but now we have a 5th digit that we're going to choose. So that's another 6 choices we have, and those are all going to get multiplied together. And now we have 6 to the power of 5 instead of 6 to the power of 4, and that jumps up all the way to 7, 7, 7, 6. So the probability of somebody breaking into that and getting it correct is 1 out of 7, 7, 7, 6. So it's a huge difference you can see between the two, and why having that added digit really increases your security. So go ahead and give that problem a try.